Alright, so welcome to this video. This is the tutor. I have a physics question for you here, which says you state Newton's second law of motion, and we also have to answer the other question there. Okay, so without wasting much of our time, we can answer this question. So state Newton's second law of motion. So Newton's second law of motion, it states that, okay, it says that the resultant force acting on the body, okay, so the force acting on the body is direct proportion to the to the acceleration and inverse proportion to the mass of an object. But you can also define it using momentum, where we say it's just the rate of change of momentum. All right, the force is equal to the rate of change of what? Of momentum. Now, answering question B, which says the following diagram shows a 4 kg box resting on a frictionless surface with forces acting on it as shown. So we can see forces that are being shown here. On the right side we have one force, and on the left side we have two forces. Calculate the uniform acceleration caused by the forces. So we are going to use Newton's second law of motion. We know that Newton's second law of motion says resultant force is equal to mass times what? Times the acceleration. So we are looking for the acceleration. We have mass, so we need to find our resultant force. So resultant force, so our resultant force here is equal to, you need to take into consideration the forces that are here. Okay, so on the right side and on the left side. So on the right side we have one force, the 10, and on the left side we have 16 and 12. Okay, so the difference between these will give us the acceleration. So the question is, it's resting on a friction surface with forces, so it's not moving, but it's just resting. So the difference in the forces will give us that the resultant force. So on the right side we've got 10 newtons minus, on the left side we have 16 plus 12. Give us 10 newton, so I put newton there. So 16 plus 12 we get 28 here, and minus 10 we get 18, negative 18 actually. So Fr is equal to negative 10, sorry, negative 18 newtons. Now the negative is just giving you the direction in which the force is going. Okay, it just gives you the direction. It's okay if you write 18 newtons, then you put the direction to the left. There's no problem. Trust me, there's no problem. So how do we find the acceleration? We have the mass is there. We have the resultant force. So the acceleration is equals to resultant force. We divide by what? Mass. And the resultant force is 18 newtons, and the mass is 4. Like I said, there's no problem putting acceleration negative there. You have no issue. So our answer becomes negative 4.5 meters per second per second squared. Or you can say retardation is equal to 4.5 meters per second squared, because since the forward force is less than the backward force, so this is not moving forward, so it's moving backwards. So it's being pulled backwards, so it's going in the negative direction. So that this is how we are supposed to answer this question.